Okay, so it's no surprise we have an exam on Monday. And so yeah, that's right, coming up. And I got to go back to my office and write it real quick. So the thing is, it's going to be the typical 11 questions, multiple choice, and then one or two open-ended questions. And I'm really onto this checklist idea. The AQ course that I'm taking on teaching tools and techniques talked about an assignment checklist and also providing exemplars, like example work for the different levels of achievement. And I did that last fall, and I got some good feedback from you guys on it as to what a good question answer was, what a moderately, adequate answer was, and what an inadequate answer was. But I thought about making a checklist. Now, this isn't really anything you need on the exam, but you should look at this carefully to kind of go through what these items are. So let me read through the checklist. So your answer that I'm looking for should have these kinds of things in it. It's not just about getting the right number, okay? So if it's a calculation, I should see the appropriate equation. And then look at the second one. I shouldn't see a whole lot of other equations on there. Like for you to just write out a whole bunch of stuff hoping that you'll get credit for the right one and I won't see the others. What I'm looking for is that you understand what I'm asking, because it's not the first time you've seen that kind of problem. Okay? Now, it may be the first application of that problem you've seen. Like it may be a synthesis question where I ask you, apply your thinking in terms of, say, an ideal gas to this other situation. And so you use the ideal gas equation, and so you apply it. But you also can walk me through, if you look at the next ones, clear statements of any assumptions. Like if it's computed for 1 mole or for 1 particle, you can tell me what you're doing. Let's say you did all of these calculations and you put in 1 mole. Okay, it really isn't going to change things, except you're going to have a per mole in there that didn't cancel with anything. Okay, but if you said I'm assuming for 1 mole and you did everything else right, that's not going to be a substantial loss of points. So you told me what you were doing. Assuming room temperature. You don't have to write assuming room temperature if it's in the problem. If it's stated, calculate this for room temperature. But if it's not in a problem and you don't know what to do, tell me what you're doing. Say, I'm doing this calculation at room temperature. Okay. Or assuming ideal gas behavior. If you've got a volume in there and you want to get rid of it, and you're going to put in nRT over V to get the pressure, or nRT over P for volume, then you say assuming ideal gas behavior, and you make that substitution. I'm not looking for a whole long paragraph, but you guide me as to how you're doing the problem. Units are important. I want to see units on the computational result, but also in the intermediate steps so that I can see them cancel. And if you look down at the bottom in that little table, this is the rubric that I'm going to be using to grade. Units are 20% of the problem. So you can get 1/5 if you use your units, even if it's the wrong equation, right? If I see a totally wrong approach, but yeah, you used your units. All right, you got partial credit. Okay, if your explanation, if you're telling me what your approach is, if you're telling me if the problem result is fishy, right? You're looking at partition functions, but you get something times 10 to the minus 23. You're like, man, that just doesn't sound right. Okay, I think the minimum partition function answer is 1, and I've got something that's 23 orders of magnitude smaller than that. Then explain, this doesn't look right. There's a problem here. Maybe you don't have time to fix it. Okay, test is over, but you're saying this doesn't look right. I'm giving you points for recognizing that your answer is fishy. Okay, so if you look at this rubric, no explanatory text, gross errors, a totally wrong approach, and no units would receive 0 credit. But a decent attempt is that middle column. You have some limited statements on assumptions or your approach or your analysis of your answer. You've got the correct equation, but poor execution. You've made a lot of mathematical mistakes. Or you have some units in there, but some are wrong, or they don't cancel. But you used your units, but you've got some problems with the units. That's all middle of the road, half credit type work. And then full credit work is that you've stated your assumptions, you've analyzed your result. Yeah, this looks reasonable. This is good enough. If you get the right answer and you think you're confident in it, this looks reasonable, and you might say why, or correct approach with minimal guesswork. You've got the right equation and you don't have lots of extra equations thrown in there just for good measure. and then also a good use of unit analysis. That would be full credit. Okay. Notice that the right answer is only one small part of the checklist. So it's not just about getting the right answer, it's also about telling me that you've learned something. That's what I'm trying to get out of the exam, is that you've studied this part of the material and you have a good idea of what you're doing. I mean, not everybody's got a perfect understanding of it, and I understand that. That's why I'm trying to give you a checklist to say, how would you tell me what you know? These kinds of the items are what I'm looking for to say, all right, this person actually knows something about this. Yeah, they kind of screwed up the calculation. Maybe they were stressed. Maybe they ran out of time. They didn't manage it well. But they've written enough on here that I know they've learned something about the material. That's what I'm after.